Now let's use our inspection methods and knowledge to check our block that we machined. Your block should look something like this. All of the surfaces should be smooth and shiny, like a mirror. We could signal the cavalry from across the canyon. Let's start with our large flat and deal with the thickness of the part. That thickness should be exactly 1 inch, 200 thousandths, plus or minus a thou. Let's check the width of the part now using the dial calipers. The width of the part should be 2 inches, 625 thousandths, plus or minus a thousandths. Let's now move to the length of the part. That should be 3 inches, 900 thousandths, again, plus or minus a thousandths. The hole that we bored in the top of our part, its diameter should be 1 inch and 50 thousandths, plus or minus 2. The depth of the hole, and we're going to use our dial caliper, and then we'll switch over to a depth mic, which is a much more precise method of the hole. With the dial caliper we get 695 thousandths. Now let's check it with a depth mic and see if they concur. Anytime that we use a depth mic, it's really important that we place our fingers along the frame, holding it firm against the base from which we are measuring. Then use our soft stop click adjustment in order to get an accurate, repeatable dimension. Our dimension is 693 thousandths on the depth mic. So you can see the dial caliper, if used correctly, is going to get you pretty close. Again, we would select the proper tool depending upon the accuracy of the inspection. Now let's rotate the block up and take a look at the slot that we machined. There's a couple of important dimensions there. Let's use our depth mic and establish the depth of our slot. That should be 500 thousandths. Remember, we made 2 passes with the mill cutter, 250 thousandths at a time. We've got a depth of 503 thousandths. Go over to the other end and check it as well. 503 thousandths. So that tells us that we had our part held securely in the vise. We didn't have any chips or debris underneath our bar that would have affected the accuracy of the bar. Now you'll also notice that we've got a second shelf, and that shelf should be a depth of 250 thousandths. Again, using the depth mic, we'll run down and check that depth. Okay, and we've got 252 thousandths. Again, within tolerance. Now it's time to check the width of the slot. Remember, when we machined the slot, we used a smaller cutter, and we asked that you offset the cutter left and right in order to widen the slot to a dimension of a ½ inch. Our part measures exactly 1/2 inch. You have a tolerance there of plus or minus 2 thousandths. We'll rotate the block now and take a look at the hole pattern that we drilled in the bottom of the block. We located the center of the block, drilled a ½ inch hole, then we proceeded to locate and drill and ream 4 1/4 inch holes. You'll notice that you have dowel pins supplied with your block. Once we've drilled and reamed those holes and we've checked our other part and it passes inspection, insert the dowel pins in the hole. Use a ball peen hammer, set them up on a carpeted bench or a wooden block, and seat the dowel pins to the depth of your hole. We'll now measure and check for hole accuracy by measuring across the dowel pins. That dimension should be 1 inch 625 thousandths. Lengthwise on the pin should be 2 inches 900 thousandths. Rotate around to the back side And again, that dimension is 2 inches, 625 thousandths. I don't want to see a variation any greater than 3 thousandths off of those dimensions. If so, a couple of things have occurred. You didn't take the backlash out of our dials when we locked the gibs in reverse direction. You drove the dowel pin in at a poor angle. Make sure that the dowel pins are driven in to the hole uniformly and squarely. We don't want them tilted or canted. Now let's rotate the block up and check the 3 holes that we drilled and tapped along the top edge. Those holes are spaced on 1-inch centers. We've centered them in the width of our block. Now, a neat little trick that you can use in the inspection room is simply use a screw, thread it into the hole, go in at least 1.5 diameters to 2 diameters of threads in order to get an accurate positioning of the screw. Then we're simply going to measure outside dimension and subtract the diameter of the screw. And this will give us our center line dimension. Keep in mind though that not all screws are exactly 1/4 inch, so you need to make a diameter check on those screws and keep that in mind when we get our overall dimension. Our screw diameters are running around 247 to 248 thousandths, and I have 1 inch 245 thousandths across the screws. So if we were to subtract 245 thousandths, that would give us the 1-inch center line that we require. Simply remove one screw into the next hole, and we're going to repeat that process. Okay, we'll grab our dial calipers and measure across the next 2 holes. And we've got a dimension of 1 inch 246 thousandths. So we've done an excellent job of establishing those holes on 1-inch center lines. Anytime that we have a bolt pattern to check, simply screwing in good screws, measuring across the outside diameters and subtracting the diameter of the part in order to establish the center line is a very easy method of locating and checking the accuracy of those holes. All right, now we want to inspect and make sure that the hole is centered in the thickness of our part. To do that, we have several options. We can set the block down in this fashion, use our depth mic over the edge, come down in contact with the screw, add 1/8 of an inch to that dimension. Okay, we've got 477 thousandths. If we add 125 thousandths to it, assuming that our screw diameter is a full 1/4 inch, that would give us a dimension of 602 thousandths. Let's go back and measure the thickness of the part. Is 1 inch 200 thousandths. Divide that by 2 is 600 thousandths. So we're within a couple of thou of having those screws centered precisely. Now our last bit of inspection is involving our center hole. How do we find out if that's precisely located? If it's a 1/2 inch hole that we've drilled, we could take a 1/2 inch dowel pin, insert it through the hole. We could use our height gauge to come in and reference off of that, indexing the part around and around and checking that dimension, or we can simply set it on our layout table using our dial calipers, measure from one end of the block to the other side of the block, index our block, and repeat that in 4 dimensions. Okay, and that will tell us if we have centered the hole properly. Keep in mind, anytime that we're drilling a thick piece of material, and by thick I mean 1 inch of thickness or greater, the drill is going to have a tendency to walk. Okay, so we want to keep that in mind in our tolerance levels. If we're going to be working on a real critical hole through a thick part, we would simply drill it undersize, set up our boring tool, and come in and bore to size in order to true the hole, and then we could ream to a specific size from there. Because that drill will have a tendency to walk through the part depending upon how much cutting fluid we're using, how sharp the drill is, how much physical exertion we're applying on the quill in order to drill through our existing part. All right, that pretty well covers the inspection of our block. I hope that yours has passed. Now let's take a few minutes and review what we've learned in this course. We've shown you the proper safety methods to use. Remember to always wear eye protection. If we're operating a machine that's loud and noisy, by all means, grab a set of earmuffs. If we're dealing with cutting fluids or in an area that is not well ventilated and we're producing a lot of toxic fumes, hook up a fan, put on a respirator. We don't want to be breathing those bad news fumes emitted from the cutting solvents that we are using. If you don't like paying the barber to clip your hair, put it up in a rubber band, a ponytail, tuck it in your shirt, or wear a hairnet. The last thing I want to see is somebody that got a haircut by having their hair sucked into a mill cutter, a drill press, or over the lathe. Keep that in mind. A lot of accidents occur every year because somebody gets their hair caught in the machine. Industrial accidents can happen easily if we're not careful and vigilant in our approach to safety. We've shown you the different types of machines as far as a vertical Bridgeport type machine, the Bridgeport itself, the aftermarket copies, what to look for in a new and a used machine. We've covered a lot of the accessories that are available, allowing you to do much more sophisticated jobs on the mill. Rotary tables, super indexers, standard spin fixtures. We've shown you the proper use of parallels, some tips and tricks to get your peanuts out of the fire, should they get there, paper shims, how to properly protect the part. We've shown you the correct use of fly cutters, standard mill cutters. We've shown you how to care and maintain those cutters for maximum life and efficiency. Never put your cutters all sandwiched together in a bag or a box, allowing them to rattle and clang around, because we're going to be dulling or chipping those cutting edges. We've gone over a lot of the aspects of multi-production parts, inspection tooling, different types of tooling that we can manufacture to allow the facility of those parts to go smoothly in a production run. Keep in mind, the imagination is a very, very important factor in becoming a good machinist. Just because somebody says it can't be done, don't take it for granted. Sit down, analyze, assess the situation, how we can hold the part, and what sequence of operations is required in order to machine that specific part. We want to always have a handle or a gripping surface on the part. Obviously, we wouldn't drill and install our 4 dowel pins and then try and machine the slot or drill and tap the holes in the other side. These dowel pins would become our Pandora's box, if you will, in trying to accurately locate and reference off of our block. Anytime that we machine a radius or a decorative cut around the part, make sure that all 4 edges match uniformly. Take pride in our work. The finished product that we turn out is a representation of ourselves. If it's sloppy, slipshod, and does not meet tolerance, we're not going to have a happy customer, and we're going to end up getting a job at the local 7-Eleven rather than operating a profitable machine shop. Well, that pretty well covers it. It's been a real pleasure working with you, and I'll look forward to seeing you in the machine shop.